for this company. It looks like I worked for Bluesky. They said it was Blue Sky, so I'm going to take their word for it. That's what we call it. We call it Blue Sky. And I was talking to this, to one of the bosses there. So we had a group of 6 programmers. This is before I knew how to program. I was a project manager and we were working on a project. So I was working really close with the programmer. Great guy, Tyler, still my very good friend. We've had a lot of great work together. So he's this programmer and he's sharp. I mean, he was the kid who went to the library, read programming books, taught himself, went to college, did phenomenal. So we're programming this project, and I would start to ask him, like, which programmers do you like working here? I'm starting to get the idea how programming works, seeing the logic. I didn't know how to write code, but I could read it a little bit. And he points at this kid. He's like, that kid right there is my favorite programmer. And so I asked him his background. He's like, he went to a semester of college, but he built all these little programming projects, and he finally built this system that would manage email lists and list management, allow you to split it and merge it. Unsubscribe. So we built this list management system just for fun because he wanted to do stuff with data, and Blue Sky bought it and hired him to run it. And here's this kid who has 1 semester of college under his belt, making more than these other kids who were still making great money, who were graduated from college. I don't want to put college down. What I want to say, and this kid could have gone to college and got through it, he'd still be as talented, but he was what they call a tinkerer. And when I talked to him, he said, when we hire people, we want tinkerers. We want to find out what's in your portfolio. What have you built? Where's your ideas? Another great example, my brother, I started a company before Simply Coding where we were working with programmers, hiring programmers. I hired my brother to help me run it, and I loved working with him. I wish I still was, but he decided he wanted to go get a programming job, and he built his project that he wanted to do was called the Twitter API. He wanted to learn API. So he would take Donald Trump's tweets and he would translate them using Google Translate through code, through the API. He would tie into Twitter, he would tie into Google Translate. He would pull down Donald Trump's tweet, translate it into Russian, and then take that translation, translate it back into English, and then post it. It was this Russian Trump bot. And it would come out kind of funny, you know, once you translate it twice from Russian back to English. I don't think it made any more or less sense. But that was his project, and he went and he showed that to a company. I know how to do APIs. Look at this project I did, and they were blown away. They said, this is perfect. This is what you're going to have to do with our company. You're going to have to pull down data, manipulate it, and push it somewhere else. And so that was his project that got him hired. And he did some other things, but that was one that he liked. In the interview, it came up and they talked about it. But that's how interviews go in technology. You know, what have you done? What have you messed around with? What have you tinkered with? Tinkering is very important. While we're doing our courses and we're working with these great kids, and we love the middle school age group, we love the high school age group, but we like to see them mess around with our lessons. It does a lot of great things for them. So what is tinkering? So a tinkerer edits and rearranges the code after doing the lessons. I'm talking specifically what I see. You know, I run after school programs, summer camps, we have our online courses, we work with independent schools, charter schools, we have our homeschool groups. And so what are we trying to get these kids to do? We want them to not fear mistakes. We want them to not fear messing up. We want them to edit, rearrange. You learn this from the lesson. What can you change? And it starts off by let's changing the size. Let's change the speed. Not necessarily adding new code or taking away new code or coming up solving these problems, but just start to edit. See what it does. And we'll talk about the computer languages that we use that kind of give way to this type of thinking. So we want them to be a tinkerer who edits and rearranges the codes from the lesson. The next step of that is we want you to come up with your own ideas and implement it into their projects. So we're going to have them build a project. They're going to build like the Pong game. They're going to build a little Mario game. They're going to build this fun little fish game. We want you to take that existing code and now just add to it a little bit. What if we put an explosion here when these two things collided? What if we had the image change after this happened? What if we made a power-up into the game? So taking existing code and just building onto it a little bit. That's a great sign of a tinkerer. And then the last thing, and this is our job, this is what I put on our shoulders, is we need you to now plan out solutions to solve their questions. We do this through, you're going to build a custom game, start to finish. Now you've gone through the lessons, you have these resources, but now it's time to plan it out. Plan it out on paper, plan it out in your mind, What are the relationships with this? And so that's where we want to get them. And they're going to recognize these things in their gaming. They're going to recognize it as they played Fortnite or Minecraft. They'll come up with ideas and they'll say, okay, I want this interaction to happen when this event occurs. And we want to break that down into computer logic so they can start thinking abstract. I love coding because of its abstract nature. I don't hone in on the specifics. I just think, okay, I want one thing to collide with another thing and it produces this outcome. And that's how code's written. And when you can start thinking like that, then you can start putting lots of different specific situations into that scenario. So why do we do this? One, kids have fantastic creativity. They have fantastic curiosity. We want to feed that. When they're editing and rearranging their code, that's when the curiosity is starting to build. That's when they're getting engaged with the code and they can start to understand how these couple lines of code really affect the game. And that's valuable in the business world. So we want to build their curiosity and engagement. That's why we gear these editing and rearranging parts. We want to see their confidence grow. So I work with these colleges and they get all these freshmen coming in as saying, I want to be a game designer, I want to be a computer programmer, I want to be in IT, I want to be cybersecurity. And their first exposure is in college as a freshman. And so I talk with these deans of the computer science departments and they tell me, this isn't across the board, but a lot of the colleges I work with, 50% of their freshmen drop out of the computer science major after their freshman year. Number one, they said, we also have 50% who have never done any code. Now, it's not the same group, but about half of the kids have never done any code before. That's an expensive experiment to try and code at that age. And it's not necessarily they just haven't done it. And it seems like a cool idea, so they come in as a freshman and they want to code. Half of them end up dropping out. And they just don't understand the learning curve. They don't understand what it takes. Not to mention, your freshman year of college can have all sorts of stress. And if that's an area that requires some learning curve, a little bit more focus, sometimes it's easier just to go in a different direction. But computers are great. Kids can understand coding at this age, at middle school, but some of them don't like it. And it's not a bad idea to find out if they don't like it at this age, or at least they know what it is. Now, as a business owner, I'm not coding as much. And so I don't have to know all the ins and outs. And I'm not listening to the podcast all the time anymore, but being able to talk to a programmer who I've given a project goes miles in my business, where I understand what they're saying, I understand their timelines, I can now kind of speak their language, and I understand what they're talking about and why something's going to take as long as they say it is. And so maybe they're not going to be a coder, but number one, knowing what it is at a younger age so they can make that decision as they get older. And number two, they could go so far into it where they now understand it, and now it becomes an asset as they are a project manager working with coders down the road. So by doing these lessons and by coming up with your ideas and implement it, we want to build their confidence. We want them to feel comfortable. When you look at code, it is uncomfortable. Your first time looking at JavaScript, I was like, very uncomfortable. Especially if you're looking at Perl, an old language. It's just slashes and semicolons and parentheses, brackets all over the place. It's an uncomfortable area. There's a learning curve. So we want to build their confidence. We want them to get used to seeing brackets. And that's why in our lessons they code from blank template. They're going to have the real environment on their computer. They save all their stuff to their computer, and they're going to learn how to code. Now we want them to plan out, not just plan out. They're writing these out. They're really drafting a storyboard before they start coding when we actually get to their final project of building a game, for example, coding a game. So that's now going to show their understanding of computer logic. Everyone's heard the adage, you don't really learn something until you teach it. And that is true. As soon as you start to actually having to do something on your own and explain it, even if it's explaining to yourself, I know a lot of people who read out loud, so they're like, I can understand it a lot better. When you're explaining something even to yourself, it allows you to dive deeper. It allows you to ask questions that maybe you're uncomfortable asking a teacher. So this is what a tinkerer is. That big long spiel, I didn't plan on spending this long, but I got going. I don't always get going. I'm usually pretty short. But this is what we're after. We want them engaged. We want them editing, rearranging. Do not fear mistakes. We have live chat support. We can put it back if it comes to that. Don't fear mistakes. Let's mess around. Let's ruin it. See if we can put it back together.